Yes, Shailesh, very good afternoon. Very good afternoon. Okay, so yeah, okay, so is everything fine? Am I audible? Because I think internet is having some issue. Oh yeah, it's fine now. So yeah, in this session, in this series of classes, so I'll be taking these kinds of classes every day, and in this series of classes I will be taking questions from Clayden. It's a very famous organic chemistry book, and different kinds of question, different kinds of approach we will be choosing. Okay, and we will be solving all those questions from that particular book. So every day there will be live classes, and 5 questions will be discussed from that book Clayden. So once we finish that book, we'll be moving forward to another book like Carruthers and Jerry Mars, like those kinds of books. Okay, so in this class I'll be taking 5 questions from Clayden and discuss. In the next class that I'll be taking tomorrow and discussing another 5 questions, and every day we'll be solving some questions on a particular book, so that like there is no time to read books. Okay, Clayden books is more or less 1000+ pages are there, but if we solve some questions, some selective questions, some important questions, we can check our knowledge corresponding to that topic, right? And at the end of the day we can then revise that book or revise that part from our sources, different sources. Yeah, so I know that maybe some of you has already that book, or some of you may not have that book, but nothing to worry. This session will be only for questions. So just tell me one thing, should I start now? Should I start now? Tell me one thing, just should I start? Are you ready? Yeah, Anubhav, Shailesh, Rakesh, yes. Should I start? Are you ready to solve? Okay, I think other students are also joining, so just tell me, should I start? Then I'm starting. I'm giving you the first question, and you have to answer me the questions within 1 minute. Okay, 5 questions, it will take maximum 20 minutes to finish the live session. First question, you have 1 minute to answer this question. Actually I posted this question in my community box, so I hope you answered this. Most of you already answered the correct one, but some of you given like maybe 1-2 answers I have got already, that those are wrong, but most of you gave me the correct answer. Okay, so which one is the correct out of this? Because this question I have posted already, so you already know the question. So again, comment down. First of all you have to comment down, then I will be explaining why is that correct. Okay, this is very basic questions, and I'm starting from very basic questions like that. And if you can answer all these 5 questions, that means you are in the right pathway to learn the organic chemistry. Okay, which is the correct answer in this question? So it is saying the interaction between NH3 and borane. Borane is what? Borane means BH3. Okay, and like you know, diborane means what? B2H6. So borane is BH3. The interaction between NH3 and borane is due to which? Overlap between NBO. NBO means non-bonding orbital of ammonia and sp2 hybridized orbital of borane. Okay. Second, overlap between non-bonding orbital of ammonia and vacant p orbital of borane. Third, overlap between bonding orbital of ammonia and sp2 hybridized orbital of borane. Fourth is bonding orbital of ammonia and vacant p orbital of borane. So which one of this is correct answer? Which one is the correct one? Yeah, comment down. Which one? A, B, C, D. What do you think? Yes, Shashank, thanks. Answer this question. I'm expecting this question. I am expecting this answer of this question from you. Which one? C. Okay, Shailesh, you are saying C. I mean this one. Anybody else? Any other answer? Shailesh is saying C. I mean this one. Any other answer? Or you are confused, or you are not like revising these things? These are very basic questions, and you have seen sometimes in IIT JAM and even NET GATE exam, or even like those kinds of M.Sc entrance examinations, some basic questions are asked, and these are one type of those basic questions. Nobody? Okay. Shailesh, the answer is not C. The correct answer is B. Do you know why? Yes, Rakesh, very good. It's B. The reason behind is let me explain this thing. So we have this ammonia, and this ammonia does have this lone pair, and this lone pair basically stays in the sp3 hybridized orbital. Why? How I can say it is sp3 hybridized orbital? You already know that nitrogen, in this ammonia molecule, nitrogen has hybridization sp3. Okay, so it is present in the sp3 hybridized orbital. Now question arises, in these orbital you have this lone pair of electrons. Now are these orbital, or is this orbital form of bonding? No, it is not forming any kind of bond. These orbital, those are forming with a bond with hydrogen atom. This is not the bonding orbital, this is non-bonding orbital, NBO. And in these non-bonding orbital you have this lone pair. So whenever you are having this boron means BH3, and in the boron has like sextate, that means there is no extra electron on boron. So you have 3 sigma bonds, that means it has sp2 hybridized orbital, and there is 3 sp2, 1 sp2, 2 sp2, 3 sp2. That means another p orbital is there on boron, which is vacant p orbital, which is unhybridized. It is what? Vacant p orbital. So whenever electron is transferring from ammonia to the boron, it is going from this non-bonding orbital to this vacant p orbital. Okay, that's all. That's the answer. I hope you have seen this, understood this one. So option B will be the correct one. So this is the very basic questions. You can think, okay, why I am asking these kinds of questions? Because sometimes questions basically come from a very basic thing. Option B. Next question. So this question is saying which of the following statement is correct regarding these nucleophiles. Okay, you have like this one, like I am giving you a lot of things. This question may be a little bit wrong. Okay, I have to give with regarding these systems or molecules. The question is a little bit wrong regarding these molecules. Okay, so now you have ammonia, Br minus, this one, and LiCH3. Now question arises, the options are only one is nucleophilic in nature. Option B, 1, 2, 3 only are nucleophilic. Option C, all are nucleophilic. Option D, none of these are nucleophilic. That means you can already know that option B is not possible. You can use elimination method because this is nucleophile like that. Okay, so now out of these 3 options A, B, C, which one is correct? Anybody? Out of these 4 options, which one is correct? Anybody? This is like, question is not too much tough. This is another very basic question. So if your basic is clear, you can easily answer this question. Okay, now which one is the correct one? Option C. Okay, Shashank. From Shashank I am getting option C. Option C. Okay, anybody else? Any other answer? Option B. Okay, from Meet Patel I am getting option B. Anybody else? Rakesh, option C. I have got 2 votes for option C. Okay, Meet Patel again voted for option B. Anybody else? Any other? Okay, 10 more seconds, then I will be discussing. Anybody else? Which is correct one? Which option is correct? Option B from Anubhav. Option B. Okay, then I have got 2 votes for option B, 2 votes for option C. Okay, Shailash, option C. Paresh, option C. So I have got 4 votes for option C. Okay, anybody else? Okay, fine, I am answering the correct one. The correct answer is option C. All are nucleophilic in nature. I know you are thinking about this compound. I know you are thinking, that's why I have given this question, and this question is taken from Clayden. All these compounds are written, this is nucleophilic. How? Let me show you. First of all, nucleophiles are what? There is a shortcut that I told you that you should know, that nucleophiles, there are nucleophiles and there are electrophiles. So nucleophiles are those compounds which loves nucleus, and electrophiles are those compounds which love electrons. So nucleophile loves nucleus, electrophiles love electrons, right? Now nucleus means what? Positively charged. Electron means what? Negatively charged. That means nucleophile loves positively charged species, that means itself it is negatively charged species, and electrophiles love electrons, that means negatively charged species, that means itself it is positively charged species. I mean, and how can you decide whether it is positively charged or negatively charged? Based upon the electrons. Or if there is electrons, negatively charged. If there is no electrons, there is no negatively charged, like things. Okay. So in this ammonia, you have this lone pair of electron. That means it can be it can be donated to any other system. Like the previous example, ammonia's lone pair of electron was donating, like it was donating to borane. Okay, that means it is nucleophile. Fine. Next one is what? Br minus. Yes, Br minus does have this negative sign, so it can also donate to any electrophile. It is also nucleophilic. Number 3 is this compound, CH2 double bond CH2. So it is basically called neutral nucleophile. Do you know why? It is called neutral nucleophile. The reason behind this is you have this pi bond over here. There is sigma bond, there is pi bond, and this pi bond, you know, the pi bond is weak bond, and as it is weak bond, the electrons present in the pi bond are loosely bound. So these electrons are loosely bound, and that's why the electrons can be donated, and that is the reason why if you add some like Br2 in this system, the pi electron generally attacks in this way. That means it is behaving like a nucleophile. It is donating some electron, so it is behaving like a nucleophile. So it is also nucleophile. And the 4th compound is like LiCH3. So you know it is organometallic compound. Okay, carbon and lithium. So if as lithium is more electropositive than carbon, so carbon basically gets delta minus, lithium gets delta plus. So if you add any kind of electrophilic center, like RC double bond OH, any kind of aldehyde, what happens? This minus comes and attacks to this electrophilic center. Okay, this is electrophilic center, E plus, electrophilic center. Why? Because electrophilic center, it is attached to an electronegative atom, so it will attract the electron density towards itself. So this center will be electrophilic. There will be electron deficiency in this center. Fine. That's how it is also a nucleophile. It's also a nucleophile. Got it? So I am getting a lot of questions like from Dipangshu. Sir, I have one doubt in this question. If we replaced nucleophile from base, then and what? Okay, if we replaced nucleophile from base and okay, then answer. If we nucleophile from base, okay, what would be the answer? Okay, the question is bases are what? Bases are those compounds. Listen, bases will be those compounds which can accept proton. Like bases can accept protons. I'll be coming to that question. Okay, Divanshu, I have similar kinds of question in this session. Okay, I have similar kind of question. Bases are basically those which can donate its proton to other systems. So ammonia, yes, it can donate. It can donate other system, or it can take one H plus ion. Okay, it can take one H plus ion. So ammonia can behave like a base. Yeah. Br minus, it can behave like a base. Like you have already read conjugate acid base pair, so you can get it. It's also conjugate base. You can consider. So it also can behave like a base. But if I talk about this compound, directly it is not coming to the basic category. No, directly it is not coming to the basic category. No, you can't say that. Bases are basically that accepts proton. Now this one basically accepts proton, but in generally only if you like if you give some alkene and then H plus, so directly it doesn't come in the base category, but it can behave like that. So it would be better if I tell you that it is a nucleophile. Okay, so questions will be set up based upon the options. So this question is not set up for the basic nature, it is set up for the to get the nucleophilic nature. Fine. And similarly this one, overall it's a stable molecule. So if I consider it can it behave like a base? Yes, it can behave like a base, because with this negative delta minus, it can go and take a H plus ion from an acid. It can do the reaction, so it can behave like a base. Okay. For bases 1, 2 and 4 is possible only. Yeah, like this I told you. So it directly you can't say it is a base. In reaction it is possible, but it cannot behave like a base. If you add a H plus ion and if you add this one, there is no reaction. There will be no reaction between them. But it can behave like a nucleophile, a neutral nucleophile. Okay, that's all. Next, moving to the next question. Now this is very important question. Okay, this is very important question. Even maybe in some cases I have seen this question before. Okay, so which one is the correct one? Which one is the correct one? So now, Dipanshu, your concept will be clear. I am giving you this NaOH, and what is NaOH? NaOH is the base, and base basically does what job? It basically accepts proton, right? Now answer this question. Which one will be the correct answer out of these four? There are a lot of possibilities. Whenever I am adding this NaOH, you will be getting OH minus, and this OH minus can attack like everywhere. Yeah, it can attack at a lot of places. This place, this place, this place. A lot of places are there where the attack will happen, and what would be the product out of these four. You have 30 seconds to answer this question. After 30 seconds, I will be explaining this one. Again, this is a question from Clayden. 30 seconds. You have 30 seconds, 30 seconds, okay. From Parag, I am getting answer A, okay. Parag is saying option A. Anybody else? Any other answer? Okay, if you are thinking your answer is wrong, nothing to worry, just answer. Either you will be right or you will be wrong. Then what? You will be getting the explanation. Again, I am getting another answer from Rakesh A, 2 votes, Dipanshu A, 3 votes, then which one? Okay, no other option. Anybody else? I can see 2 students are watching, so please do comment. Please do comment. Like these kinds of questions, like you are not quite sure about this thing, right? Okay, fine. Let me discuss this thing. Okay, Shashank is saying option C. 1 vote for option C. Anybody else? बहुत लड़ाई चल रहा है ना. Meet Patel, option C. Okay, option C is very close to option A. Anybody else giving answer option C? Anybody else giving answer option C? Okay, D may be, okay, Parag, D, okay. Then Shailash is saying option C. So I have got 3 votes for A, 3 votes for C, and 1 vote for D. And Meet Patel option C, okay. Okay. Fine. Yeah. So now these kinds of questions are very sensitive because like there are a lot of possibilities and you have to do it well. You have to do it well. So open your copy and pen, then do it, then answer. The thing is, like if you are saying option D, let me prove that you are wrong. How would you make this product? Through mechanism. Option D is not correct. Option D is wrong. How would you make the product? First of all, you have this OH minus. Just try to visualize. You will be attacking over here or over there, right? And then what? Then this bond or this bond will break, so you will be getting O minus. And then what will you do? This O minus will be present in the ring. O minus needs to form in a ring, needs to be present in a ring. So where do you attack with this O minus? Here, it's impossible. SH group is not a living group. So how this group can live? Okay? Because you are adding base, you are not adding any kind of H plus ion. So it will become OH plus, then you can break this bond like that. No. You are adding OH minus base. So Dipanshu, I hope you are there. And the correct answer for this question is neither A, neither B, neither C, neither D. Okay, I have told everything is not. The correct answer is option A. As you told me. Raj, very good. Option A is the correct answer. Why and how? No, partially no, it's not correct one. Let me prove you. Let me show you how option A is correct. And let me give you the correct explanation. So whenever you are saying any option is correct, please do the mechanism, okay? How option A is correct? First of all, we are adding NaOH, which is a base. So first of all, what bases does? What bases does? Bases basically tries to find proton. Like I have OH minus ion. OH minus ion will try to find a proton, right? It will try to find a proton. So first of all, if you have this SH group and there is a proton over here. Now base can obstruct this proton, but the condition is this proton needs to be acidic. Now how can I decide whether a proton is acidic or not? How can I decide that? It can be decided based upon the stability of the conjugate base. How? So let me make the conjugate base. Suppose I am thinking that this proton is acidic proton. It is OH minus base is coming and abstracting this proton, and you are getting S minus. First of all, what you are getting exactly? S minus. Now you already know sulfur does have its vacant 3d orbital, and this negative charge is not participating in any kind of resonance or hyperconjugation or like that, but it can present in that, extra electrons can present in that vacant 3d orbital. That means this compound is stable. This compound is stable. Now after this you have two possibilities. So let me write this compound in this way. Let me write this compound in this way. Okay, now you have two possibilities. Either it will attack at this position or it will attack at this position. So if it is, okay, let me use two different colors. So if it is attacking at this position, then this bond will break, and if it is attacking at this position, this bond will break. Now which one will be the correct? Which one will be the correct one? So as I already told you, option A is correct. That means 5-member ring will form. That means S needs to attack at this position. At this position. Okay? At this position, not at this position. Now question arises why? Why it will attack at this position? The reason behind this is, try to understand. If this bond is breaking and positive charge is forming over here, it is a 2-degree carbocation. I am talking about driving force. Why it is coming over here? And if this bond is breaking, a carbocation is generating which is 1 degree, not that much stable. Which carbocation is more stable? 2 degrees more stable. So already in the system there is a driving force which is, and what kind of driving force? Oxygen is more electronegative atom, carbon is electropositive atom. So oxygen will try to attract electrons towards itself. So already there is a electrophilic nature present over here. And here and there, where there is more electrophilicity at this position. Why? Because if positive charge generates at this position, that would be 2 degree. At this position, it would be 1 degree. 2 degrees more stable. So there will be driving force which always tries to generate a positive charge, more stable positive charge over here. And that is the reason why the green color attack will not be possible, or will not be like there. Only white color attack will be there. And whenever this attack is happening, your product will become like this, sulfur and this, and finally this O minus. Okay, now initially you had this OH minus that took up this proton. Now again if you have this water molecule HOH, so this O minus again take this H plus from water molecule and it will become SOH. That would be your final product, and that is nothing but this one. Okay. Second, okay, so I am getting another suggestion from Parag. Sir, first epoxide ring attack nahi hoga kya? So now listen one thing. Suppose you have this OH minus base, okay, but you are attacking to this epoxide ring. Okay, I am attacking. Suppose think, Parag think, I am attacking to this epoxide ring. Okay, suppose I am attacking over here. Suppose, or over here, wherever you are attacking is not, doesn't matter. This bond is breaking or this bond is breaking. That means you are getting O minus and you are getting OH. Then what? Then what? What will happen? So you are thinking, okay, now this O minus will attack. Where it will attack? Here? No, this is not a good leaving group. SH is not a very good leaving group. Now what would you do then? There is no option. Your reaction is impossible. You can't do the mechanism. And you have this OH minus base that will find a proton. It's a general acid-base reaction, like Raj said. It's an acid-base reaction. Okay, try to do whatever you are thinking, try to do on your copy, and then you will be stacking, you will be getting stacked. Okay, you can't do the complete mechanism if you attack over here. Clear, Parag? Okay, I think it's clear now. Next question, this one, question number 4. Which one is the correct answer? Now you have to like storm your brain to answer this question. But this question, okay, I am giving you the chance to answer this question. Which one is correct? This is the initial reagent. You have got A and then you are adding this, you are getting B. Now you have 4 different options. Which one is correct? Again I am telling you, it's also a Clayden's question. I have got this question from Clayden. And these questions are very basic questions. You will be thinking, okay, this may be the correct answer and also this may be the correct answer. But the exact correct answer will be like very easy, but as it's a Clayden's question, so there will be a standard of those questions, okay? So try to answer A, B, C, D, which one? I am giving you 30 seconds to 45 seconds to answer this question. Which one is correct answer? Tell me. Which one is the correct one? Okay. Anybody? Okay, do it on your copy and then tell me. I'm giving you much more time than that, but do it on your copy. Don't think, okay, it will happen and then I'll be getting the product. Do it on your copy and then answer it. And if you are like going away from these kinds of questions, that means you are missing something. So please try to join this session every day so that you get to solve these kinds of questions from like a very good books, that is Clayden. Okay. Which will be the correct answer? Okay. Rakesh is saying option B. Okay, fine. Option B. Then I am for partially saying option C. Any other? Anybody else? Okay, Ashish, I was not prepared for jams. Can I clear DU entrance with good rank? Listen, Ashish, if your concept is cleared, you can clear anything. Okay, that depends upon you. Okay, I don't know how much concept you have already cleared. So please take some time and try to solve the previous year question. If you can solve previous year questions, you can easily solve other questions as well. Okay, Parag is saying option C. Again, I have got 2 votes for option C, 1 vote for option B. Now, anybody else? Dipanshu, option C, 3 votes option C, 1 vote option B. Anybody else? Any other? Relaxing music, option C and option, okay, 4 votes for option C. Anybody else? Any other? Okay, 15 more seconds. After 15 seconds, I will be starting to discuss this one. Okay. Meet Patel, Showman, option C. 2 more vote for option C, and Ashish is saying option A. Showman is saying option C. Okay, so I have got at the end of the day, Anubhav is saying option B. Okay, fine. Now at the end of the day, I have got 1 vote for option A, 2 votes for option B, and 7 votes for option C. And the correct answer is option C. I know you are overthinking. I know this problem. So in most of the cases, students overthink. Like maybe here there is some exceptions. And because of those exceptions, these kinds of things happen. So listen, it's a very simple mechanism. It's not too much tough questions. You have these kinds of reagent, and how can you say it is option C, option B? How is it possible even? How is that possible? Because you have this thing already. So how you can omit this thing? How you can remove this thing? You can't remove this part, okay, through these reagents. So you have this thing and you have Cl. So first of all, you will be generating, whenever you are adding this Mg dry ether, you will be generating what? Mg and dry ether, you will be generating the organometallic compound. So it will become like this. It will become Mg and Cl. So now this carbon will get delta minus, this metal will get delta plus. In the next step, you are adding what? You are adding CO2, C double bond O. This delta minus will attack to this carbon, electrophilic center, this bond will break. So your product is this. C double O minus, or I can write it properly so that you can understand it properly. C double O minus and MgCl plus, like that. Okay, I hope you can't see this. So yeah, MgCl plus. Okay, now in this compound then you are adding what? H3O plus. Simple, it's very simple. H3O plus. And I know that these kinds of mistake you will be doing in the examination as well. Questions will be too much easier, but as you can see, some of you are like guessing some correct answers, some of you are not guessing some correct answers. Okay, and why it is happening? Because I know you know this concept, but like sometimes we overthink. Maybe it is an exceptional question, that's why it's happening. Do not do this thing. Just apply general concept. Mg ether, what it does, this one what it does. And sometimes I know exceptional examples comes into consideration, but like those are rare cases. And like how do you know whether it will be exceptional problem or whether it will be like normal problem? That based upon your practice. Okay, if you practice a lot, you will be getting these things. Okay. So sir, but how can the breathhead position insertion is possible? So are you doing, Rakesh, are you doing any kind of stabilization like things that the breathhead position will interact, or breathhead position will like cannot do the resonance like thing? So you have this breathhead position. How the breathhead position looks like? So basically the compound is looking like this, right? It is compound. This position is called, this position is called, this position is called breathhead position. So here MgCl is forming and then it is attacking with CO2 and COOH is generating. Simple. Again, it's a Clayden question. Okay, from the next session I will be giving you the page number of Clayden. Okay, and once this live session is over, you will be getting the PDF of this video. Okay, next. This is the solution. Next, question number 5. You have to answer this question. Like it is the toughest question that I have set up today. Maybe for me, but not for you. So take your time and solve it within 1 minute. The last question that you have to solve. Which one is correct option? So it's looking like a bulky structure, but you have to apply general concept. That's all. You have to apply some general concept. That's all. A, B, C, D. Which one is correct? Take your time, do it on your copy, then tell me. Ting, 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 ting. Okay. Option A. Okay, I have got 1 vote for option A. Then R. S.R. Panda. Okay, option A. Anybody else? Anybody else? Option A. Okay, you are saying again option A. Okay, let's see. Again, this question is from Clayden. So once this live session is over, you will be getting the PDF file of this notes. Okay, PDF file in the description box. Option D. Parag is saying option D. Okay, 1 vote for option D. Rakesh is saying option D. 2 votes for option D. Then Pradeep is saying option D. Wow, 3 votes for option D. Anubhav, option D. Oh, option D. I think option D will win the match. Okay. 4 votes for option D. Vishnu, okay. Option A is also winning. Option A. Okay, I think two double bonds are missing in option D. Oh yeah. Yeah, I just missed these two. Thank you so much. Thank you so much. Yeah. I mean, everywhere in every examples double bonds will be there except this because I have reacted. So yeah, double bond will be there. Thank you so much. Option D, Sandeep, option D. So I know you are getting confused at this with this structure, right? Now I am giving you some hints. This is nothing but this. So you are getting confused with this N. Forget about N. This compound is nothing but this formaldehyde. So I think Shubhradeep option D, I think. Okay, another vote for option D. So 2 votes for option A, 5, 6 votes for option D. So it's a democracy. So what happens in democracy? Number of votes wins the match. So option D is the correct one. Very good, Rakesh. Yeah. How it is happening? It's a very interesting reaction. So let me copy the reaction first. Copy the reagent first. So first of all, I am adding this BuLi. Okay. I am adding this BuLi. Fine. So here you can see it's a triple bond. So that means with this carbon we have one hydrogen atom already. And I am adding BuLi. BuLi means what? CH3, 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 CH2, CH2Li. So it is getting delta minus, it is getting delta plus. So now this delta minus is attacking to this proton, and now question arises why it is attacking to this proton. Yeah, I know this is organometallic compound, carbon would get the negative sign, negative charge, it's okay. Why this proton, it is attacking this proton? So this is a negative sign on carbon. Yeah, it's fine, it's basic, it's nucleophilic, okay. But what about this compound? Why this proton is acidic? The reason behind this proton is connected to sp hybridized carbon, and in case of sp hybridized carbon you can see it is sp. That means 50% S character and 50% P character are there. Yes, 50% S character and 50% P characters are there, and that means that is the maximum amount of S character can present in a system. So you already know that S character is proportional to electronegativity. So although carbon is electropositive element, but also as the S character is 50%, so it behaves like a electronegative atom, and as it is electronegative atom, it will attract the electron density towards itself from hydrogen, and because of that these hydrogen would be acidic hydrogen. And as I have acidic hydrogen, therefore CH2 minus will take up the acidic hydrogen, and a negative sign will be generated over here on the carbon, on this carbon. Yeah, and whenever negative charge is generating, let me copy the structure and draw the structure once again. Draw the structure once again like this, and then this and negative sign over here. Okay. Now once I am getting the negative sign over here, then what I am adding? I am adding this compound, that is nothing but HCHO, formaldehyde. So formaldehyde, HCHO. Okay, so this negative sign will come and attack to the electrophilic center, and this kind of reaction will happen. And because of that, I will be getting what? I will be getting same compound, along with that this triple bond, then this bond, then double single bond O minus CH2. Okay, in the next step I am adding what? I am adding some H2 plus. So the O minus will become what? OH. So what I am getting? Triple bond CH2OH. Okay, this would be your correct product. Again, this question is a Clayden question, so you will be getting the PDF file of this, the whole PDF file after this live session. Okay, now someone was saying option A is correct. Now question is how it can be correct. You are thinking this proton is acidic, but this proton is connected to a sp1234 sp3 hybridized carbon. So this carbon has S character only 25%, and this carbon has S character 50%. So which carbon is more electronegative? This carbon will be more electronegative, so the corresponding proton attached to this carbon will be more acidic. That's why here there will be no attack possible, and this is impossible. How you can get this product eventually, because you are not doing anything else, just adding a OH group, but you have other reagents as well, right? CH2, I mean this one. Fine. So that's all about this session. So these kinds of question actually I also discuss in these groups, in these batches, so where I take daily live classes. So if you're interested to do this, you can join. Otherwise I am getting other questions like, sir, please upload JAM counseling regarding counseling. Okay, Actually, whenever the form fill up process will be started, I'll be doing that job. So the form fill up process is not started yet. So whenever it will be started, I'll be showing you everything, that how to fill up form, how to do the counseling, everything I'll be telling you in the live session. Okay, I'll be coming in live and I'll be discussing all the questions. Okay, so please give the page number of this question from Clayden. So okay, so what I'll be doing in this, from this session I can't do this job. From the next session, like tomorrow, I'll be doing this job. Okay, I'll be giving you the page number of Clayden so that you get to find all these things, and also I'll be adding the PDF file of Clayden so that you can download it from the description box. Fine. So thanks.